first of all, thank you to the organizers for this invitation in this wonderful event. Myself, Dr. Dhriti Ghosh. I am an associate professor in the Department of Physics at IIT Dharwad. And the title which I'm going to talk about is about kitchen-grade aluminum foil for substrate-cum-electrode for perovskite photovoltaics. And the picture here you see is the artistic view of the kind of the work which we wanted to do. And before we move on, I just wanted to let people know that from where I am. So this is the map of India, and we are situated somewhere around the southwest part of India. And this is the location where we are. And just for convenience, I have, as you can see, this our institute is close to three major cities in India, which is the Mumbai, Hyderabad, and Bengaluru, which is a kind of equidistance from these three main cities. And I hope that probably some of you have heard of these big cities from India. About this institute, so we are in IIT Dharwad, which stands for Indian Institute of Technology Dharwad. And this is a pretty new institute. We came into the existence in 2016, and we moved into the new campus only last year. So these are the few of the pictures from the permanent campus, the brand new campus which is built in. So this is the admin building. This is the building where I sit in and my lab is situated. This is the central lecture theater where we take our classes, and this is the kind of the data center or the library. And this is my current lab here in IIT Dharwad. We named it as Thin Film and Photovoltaics Lab, TPL in short. And these are the kind of instruments which we have till now. Again, this is an upcoming lab. We are still building it. So we already have the glove box with integrated evaporator and e-beam. We have some spectrophotometer, weighing balance, spin coated, and others. We have quantum efficiency, solar simulator, 4-point measurement systems, and we are developing it even further more. So coming back to the topic itself, which is about the utilizing aluminum foil for perovskite photovoltaics. So let's come to the motivation. So the motivation was that, imagine if you have a car and you would like to, functionalize some of its properties with the help of a solar cell. And if you utilize the current silicon solar cell, it will something look like this. So it is not very appealing from the aesthetic point of view. So we asked ourselves, can we do something on this? So we then aspire to do something on this bendable and lightweight photovoltaics. So if you can make some perovskite photovoltaic cells and flexible, then the integration will be much more smoother, and from the aesthetic point of view, it will be much more, better. So with this motivation in mind, we asked ourselves, what can we use? Of course, the obvious choice is to use plastic substrates, but we wanted to do something different. So we utilize something which is really available to us. If you take a look, this is a normal aluminum foil which we found in our kitchen, and we tried to use this. So the question was, why should we use this? Because this is aluminum foil, which is very low cost, is bendable, high conductivity, low work function. It has a high reflectance. Of course, it is diffuse transmission. It can be made of any desired shape and size. It is very lightweight, and it's very thin, close to 10 to 11 microns. So with these properties in mind, we went on to explore the possibility of using this aluminum foil for our perovskite photovoltaics. The next question was that whether we can really use this aluminum foil, which is very cheap and we can find it in our kitchen. The answer is yes. It cannot be used because the aluminum foil is not made for that particular usage, right? It is used for packaging foods. So it is not very costly as well. So what we did is that to make it more suitable for our perovskite photovoltaics, what we did is that so this is the AFM figure of a blank aluminum foil. And as you can see, it has a very high roughness, so it is not suitable for making solar cells. It has some imperfections, some defects on the surface. It's not so clean as well. So what we did is that as a first step towards this integration is that we deposited a thick layer of metal titanium sputtering, and then we heat it up. Once we heat it up, we converted some part of this titanium layer to titanium dioxide, and together we call it as a titanium oxide layer. And after we're doing that, of course, the surface properties improved, the roughness has decreased. And we also did some characterization, just like the reflectance measurements and XRD measurements, just to make sure that, yes, we have really converted the titanium layer to titanium dioxide. Now, from the device point of view, this is very important, that why we wanted to oxidize it, because TiO2 is a very well-known and very widely used electron transport layer in perovskite photovoltaics. So we chose titanium because it can be converted to titanium dioxide, and in terms of energy band level diagram, it is very well suited for using as a ETL layer for the perovskite photovoltaics. So as you can see, this aluminum foil is not only being used as a substrate